Okay, we've got this function right here, 1 over x squared, quantity x squared plus 1, and that's this red graph right here. Between x equals 0 and x equals 8, we're revolving that blue region around the x-axis. This is a typical radius of a washer. So you can picture as this rotates down to here, you get something that you might say looks like a quarter. Here's actually what that shape looks like after you've done the rotation. So this is the integral we want to evaluate. Pi from 0 to 8 of the definite integral of f of x squared. That's the radius squared. And that's like the thickness of the washer. Turns out this is the antiderivative of f of x squared. And you can see that if I evaluate the antiderivative from 8 to 0, multiply by pi, I get the same answer. The question is, how would you do this manually? Here's the integral we're trying to evaluate. When you see something like x squared plus 1 or x squared minus 1 or 1 minus x squared, you want to probably, or at least consider using trigonometric substitution. Draw a little right triangle, call this angle theta. This SST, when you use trig substitution, you want to use sine, secant, or tangent. And you like no radical to be on the leg that you're labeling the triangle with. And you can see that if I say x over 1, that's the tangent of theta. And that this gives this as the hypotenuse of that right triangle. That'll come into play later. If the tangent of theta is x, then theta is equal to inverse tangent of x, or arctan x. That means 1 plus x squared is 1 plus tangent squared, replacing the x with tangent, and that's secant squared. And dx is the derivative of tangent. So secant squared theta d theta. So we're ready to substitute all of this into the original integral. Dx is secant squared theta d theta. 1 plus x squared is secant squared, quantity squared. 2 of the secant squareds, or 1 of the secant squareds cancels out. And then secant squared is the same as 1 over secant squared is the same as cosine squared. So this is what we want to evaluate. How do you find an antiderivative for cosine squared? Well, I'll go over it real quickly. You use this trig identity right here. Solve for cosine squared. And that's what you get. So we want to evaluate the indefinite integral of that right there. And that's what I'm showing on this row. Use u substitution for this integral. Antiderivative of 1/2 of antiderivative of d theta is theta. Going from here to here, we're using the trig identity, the sine of twice an angle. It's 2 sine theta cosine theta. Now here's the key. We go back to the right triangle. The sine of theta is opposite over hypotenuse. That's where this came from right here. And the cosine of theta is adjacent over hypotenuse. And theta, this theta right here, is the inverse tangent of x. So there's our antiderivative right there. And up here, I've shown substituting 8 into that antiderivative minus putting 0 in. So, and of course, multiplying by this pot. So there's an exact answer right there. Here's an approximate answer, 2.465. you're asked around to 4 decimal places, so I guess 2.465. There you go. Hope that helped. If you have any questions, post a comment.